Urban heat island effect is a global phenomenon that impacts human life in urban centers. It results from decades of unsustainable building and urban sprawl. Day and night temperatures are at an all-time high. The primary causes are related to the structural land cover differences of urban and bordering areas. The sprawl of low albedo surfaces, for example asphalt and rooftops, have made land cover less reflective of solar radiation, and this in turn traps in heat. Unchecked, we will see vulnerable groups such as children and the elderly die from heat waves and sustained high temperatures. At some point, if we don't take action, areas like Phoenix, Arizona will be too hot to live in. People will be forced out of areas like Phoenix and will relocate to cooler areas. This will be a displacement of possibly millions of ecological refugees. The economic impact of such a reality will cost billions and, more importantly, human lives.
With approximately 65% of the waste heat being rejected into the atmosphere, AC or air conditioning is a paradox in the mix when it comes to the urban heat island phenomenon. The hotter the outdoor temperatures get, the more people use their air conditioning, compounding the problem. This waste heat makes the nighttime temps in the urban heat island rise by 1 to 1.5 degrees Celsius and continues to exacerbate the issue. In order to meet the near-term goal of stabilizing the temperature increases, air conditioning systems must operate with more efficiency and run for less time. Technology can be used to adjust temperature settings so that air conditioning doesn't run at the times when it may not be truly needed, such as when an occupant is away or sleeping at night. Here is a chart with some suggested settings from the folks at Energy Star. Adjusting cooling settings by 5 to 8 degrees Fahrenheit can reduce waste heat and create significant savings in energy costs. It is also noteworthy that doing so could mean a 12 to 1300 megawatt hour per day decrease in the Phoenix area energy consumption.
Hello. As you can see, I'm on a roof made of dark materials. These dark materials tend to dominate urban infrastructure. Darker materials have lower solar reflectance values than lighter color surfaces. This means that these dark surfaces absorb heat rather than reflect it back into space. This strategy to help mitigate the urban heat island within Phoenix is going to replace the darker surfaces, particularly roofing and asphalt, with lighter color surfaces. The U.S. Department of Energy states that since dark roofs absorb 90% or more of the incoming solar energy, the roof can reach temperatures higher than 150 degrees Fahrenheit. These cool roofs will help alleviate this extreme heat and lower the demand for excess cooling energy. In fact, according to Hashem Akbari and the Heat Island Group, metropolitan-wide annual savings from the application of cool roofs on residential and commercial buildings were as much as $37 million for Phoenix. As you can see, there are profound environmental and economic benefits that can come from these cool roofs. Dark surfaces, as we all know, are found throughout cities and actually perpetuate the problem of urban heat islands. Here's an example of a dark pavement, asphalt. By replacing dark pavements such as roads, sidewalks, parking lots, with lighter colored pavements such as concrete, temperatures within Phoenix will begin to approach the lower temperatures of its rural neighbors. It is important to take advantage of regular maintenance required for pavements and make the transition to a lighter colored surface then in order to be as cost effective as possible. Good maintenance practice calls for resurfacing a new road after about 10 years. Therefore, after these 10 years, all asphalt within Phoenix would be resurfaced with a higher albedo material. The transition to cool surfaces is a strategy that Phoenix must take in order to help mitigate its urban heat island.
A primary urban heat island mitigation strategy that should be implemented is urban greening, which is the process of adding vegetation within the city. Trees and plants not only provide cooling benefits, it also awards us with other sustainable benefits, such as energy conservation, pollution reduction, improvements on human health, and much more. Planting trees can reduce local temperatures in two different ways. First, by creating a tree canopy or shaded areas. In Phoenix, neighborhoods with a 25% tree canopy have seen temperature reductions of up to 8 degrees Fahrenheit. With the community's help, we can reach a 25% canopy coverage metropolitan-wide to help reduce the temperature. Trees also can cool the air by releasing its moisture or water vapors into the atmosphere. A strategy local businesses can employ is the installation of green walls. Green walls will cover low albedo urban building materials with beautiful lush vegetation. This wall acts as a barrier by insulating the building and reflecting solar radiation. Water demands can be high to maintain these walls, but innovative, sustainable technologies such as gray water irrigation systems can turn these water consumers to producers because of the evapotranspiration process, which makes the benefits outweigh the cost.
Ultimately, we will have to rethink the way we live in order to create a sustainable home for future generations. A paradigm shift will have to occur so that we can help mitigate the damaging effects of unchecked urban heat island. Urban greening is an excellent solution we have to help mitigate the effects of urban heat island. This simple yet effective tool can be implemented in large scale if backed by the business sector and local government. Using less energy and finding alternate sustainable sources will also greatly help mitigate urban heat island effect. We can make these and several other solutions possible if we lobby government for change. If they don't create change, we will have to demand it. We must take action because apathy will destroy our planet for future generations.